Okay, so we're back at it again. I don't have a headphone or mic, so we're just playing by speaker, I guess. Lead code 1970, today's daily. Last day where you can still cross. There is a, what? A one-based binary matrix where 0 represents land and 1 represents water. Is that? I've never seen that. Does that just mean 01? Okay. And 1 represents water. You're given integers row and column representing the number of rows, columns in the matrix respectively. Initially on day 0, the entire matrix is land. However, each day a new cell becomes flooded with water. You're given a 1-based 2D array cells. Like 1-based indexing? Is that what it's saying? This is the first day. This is the second day. This is the third day. No. Unless it means this is the on day 0 and then 1, 2, right? 1, 2. Okay, that's lame. Where cells I is equal to R of I, C of I, represents that on the ith day, the cell on the rth row and okay, will be covered with water, i.e. change to 1. You want to find the last day that is possible to walk from the top to the bottom by only walking on land cells. You can start from any row, any cell in the top row, and end at any cell in the bottom row. You can only travel in the 4 cardinal directions, left, right, up, and down. Return the last day where it is possible to walk from the top to the bottom by only walking on land cells. So on day 1, it turns into this, and then this, and then here, and then at this point on day 3, it becomes uncrossable. Okay. So this is kind of like a traversal problem, but it's not exactly like a shortest path necessarily. It's like a kind of like a how do you want to say, like a kind of limit test, I guess, is a League of Legends term. Apologies for it. And we're what we're basically saying is like, at what point of this thing can we just say, oh, stop? And obviously we could go one by one, like starting from here and check until it's like a viable cross. Like I fill in this section first and then I do a DFS or BFS and I go here. But because this is like an ordered set, we can I'm pretty sure we can binary search this, right? I think. Like we could check, oh, can I like get from here to here if I fill in these squares? I think the annoying part, if I do mark it like this way, I would have to like undo it if I wanted to like move it back, right? But I think we could avoid that by doing something else. Okay, so like we can try to search the index we want to, like, because cells is always going to be like a 2 by m. I think, yeah, it's always going to be like a cells.length is equal to row times column. Oh, is it guaranteed to fill up the entire thing? Well, if each value of cell is unique and then cells.length is equal to row times column, meaning there's n by n. Okay, I think that just means it's guaranteed. Wait. And it's one index too. Yeah, it's Why? Why? So 1, 2, it fills that one, and then 2, 1, it fills. Okay, so we get to here. It filled up. What is that? In this case, this would be 2, 2. Oh, yeah, and then 1, 1, and then 1, 3, and then 2, 3, 3, 2. Okay, so it does. At some point, it does completely fill up, so that's a good thing. There's never gonna be a point where, how do you say? I could just say we could choose, like, I guess that makes sense for the problem. It would make sense if I'm wasting a lot of time. It would make sense if we could just go on wait forever, like it never filled up. So that makes sense. What we're trying to really do is we're trying to search the index of cells, like to stop at, like to stop at. We want the index to be as big as possible. So instead of I think marking, we could obviously search cells and then for all cells with an index less than our midpoint, we fill that into our matrix. But I feel like a smarter way to do it is we pre-mark each cell with the index / day it's full on, so that when we search the day we're trying to land on, we can just check the value if let's call it matrix. If matrix I of j is less than our midpoint, then we can safely traverse. So we'll just be binary searching and then use a helper BFS / DFS function, helper function to validate if a midpoint lets us get to bottom. So I mean yeah, so we can say int right is equal to cells.length, and then int, I mean there should never be a point unless if it's a 1, it's the matrix is just 1, but it's always at least 2 by 2. It says here the minimum is a 2 by 2, so it should always be traversable even after 1 day. So let's just say int left is equal to 1, and then we can say a while, and then actually I think we should do int res is equal to -1. So while left is less than or equal to right, and then let's just return res. So, and then int mid is equal to left plus right minus left divided by 2. I always write my midpoint like this because it pretty much never fails me. I feel sometimes when I write right plus left divided by 2, it kind of messes up at weird places. I don't know why. I should probably do research and understand it. And then we'll just say boolean valid is equal to BFS, and then we're gonna write our BFS function. So I feel we could probably write it in there, but I don't know. Turn down this easy. The public boolean does it. I'm choosing BFS here because I feel DFS, obviously we could for each square we could DFS, but that sounds kind of annoying. I mean, I feel BFS just seems more natural. Maybe I'll try DFS first, because DFS usually performs better, but at the same time I don't like writing recursive functions. 'cause DFS, we'd have to make like. Oh wait, we should probably like actually make a. We should make the matrix we were talking about. Matrix equal to new int and rows. Yeah, so int is it 1? In this case, row is equal to 2. Okay, yeah. So row call and then for int cell. We should probably actually use a like for int I0 less than. Let's just say right. Reuse that. So let's say matrix. Okay. Let's just write some readable code. Int cell is equal to cells I, and then matrix of cell 0, cell 1 is equal to I. Ooh. Yeah, we should. Let's just want index that. Right. Because then we can actually differentiate it, I fear. I mean, we could just. I don't know. I think it's easier to write it like that. Because like if we start at 0 as well, then the first thing we mark is gonna be different. Okay, I'm gonna stick with this. This makes sense to me. To public do Boolean DFS, and really we just need a matrix, and then like int k, and let k be our midpoint. Oh, I really don't want to run a recursive function though. And then, you know what, I'm just gonna write private int directions is equal to new int. It's just so much more convenient to do each direction like this. 1 0 negative 1 0 0 1, and then we can do 0 negative 1. Okay. Valid. And we want to do this for each starting. Oh, that's annoying though. Okay. If we want to do it like this, then we need like a set, which I mean, we needed a set anyways. I don't know how expensive like creating a matrix each time. I don't know. I mean, that's not a big number, so maybe we could get away with using a set. I mean, yeah, like a matrix set. But each time we call DFS, I mean, we could reuse it for each like call here, and then I think it'd just be easier to write a BFS for this, but you know what they say? They say write first and then optimize later. Right? I also need a set here. Fuck it. I don't know. I'll just whatever. I don't like writing recursion, so I'll avoid writing recursion for now. Int set. Can we mark inside the matrix? I want to avoid that because this is like a binary search thing, so we're going to be reusing matrix. If it was like one and done, I would obviously mark up the matrix, but in this case, it's like a little more annoying. Actually, we probably want to use Boolean. Or would it just be more efficient to use a hash set? Yeah. Who knows? So equal no Boolean length, and then matrix 0.length, and then we say q int q equal matrix 0 dot length plus I, and we want to start at the first row. So we want to say if if matrix 0 of I is less than k, then so it's not sunken, we could say q dot offer new int. Yeah, that's expensive, but we'll live with it. 0i, and then while q dot is empty. I don't think it actually matters if we do like a true BFS. I think if we just wait. Whatever. Okay. And we'll say like int cur is equal to q dot pull. Oh, man, I really don't write BFSs. I haven't written like a B. I've just been doing too much dextras. Okay, q dot pull. And then let's just say int I is equal to cur 0, j is equal to cur 1, and I want to visit this. So we'll say set of I j is equal to true, and then we could actually just say if I is equal to matrix dot length minus 1. If we got to the bottom row, then we can return true. Otherwise, for int direction in directions, that's how I defined it up here, right? We could say int di is equal to direction 0 plus I, and then dj is equal to direction 1 plus j. Yeah, and then if di is greater than or equal to matrix dot length, or dj is greater than or equal to matrix 0 dot length, or why did I write that? Or di is less than 0, or dj is less than 0, or set of di dj, we can continue. Otherwise, or actually matrix of di dj is greater than or equal to k, we can continue. Otherwise, q dot offer new int di dj, and then if we never end up traversing this, then we can return false. So BF, that seems to work, right? And if valid, then res is equal to mid. Ooh, but if it's okay, yeah, if it's valid, then res is equal to mid, but that means we can be a bit greedier, and so left is equal to mid plus 1. Else, I don't like the way that looks. Else, right is equal to mid minus 1. Now, we hope it compiles. It probably won't. Yeah. K. Why did I write K? Mid. Oh. Oh, it's one index, right? Dude. There's probably a bunch of stuff I didn't write. Oh, that's not. Okay. Yeah, it's all -1. Why? Dude. So that means this never. Man. I mean, it ran fast, which means. I guess. Is it this? Hello? What's going on? Oh, okay. My brother's in here. Oh, I'm recording leak code again. 'Cause I like solving leak code, but, you know, I need to be able to explain it. So I'm recording myself. You can talk, it's fine. It's not that serious. Okay. Okay. It is indeed one indexed. What the hell? So is this ever valid? Hi. Well. It is not, so we need to figure out why this is never valid. What a home man. System.out. Hi. What the hell, man? 0, 0. Wait. Maybe we should do like k-1 then. Maybe. That doesn't make sense at all, but yeah, never mind. Wait. Why is it one indexed? So it starts at 0, 0. Oh, is it because of this? Oh. Everything you want, everything you. Okay, let's so. Oh, I missed that right. First by system that base that GP string matrix of I. What? Oh, is that why? Wait, what the hell? That might be it. That might be it. Okay. So 1, 3, 2, 4. Right, that check. Wait, yeah, 1. Okay, I don't know why it's breaking here, but not there. Oh, that Great. Okay, so let's be safe. Let's just change it to this. Does that mess up? No, it does actually. Indexing is stupid. What the hell's your problem, man? Index 2 out of bounds for range 2. What? Oh. No, I don't. That doesn't make sense. Great. Oh wait, not right. It should just be row. Am I fucking dumb, dude? Okay, so 1, 2. So maybe it's probably because of this greater than or equal to k. At this point, system.out.println k. The first value k is 2. What the fuck? Why would it be 2? Because the left is 1, so 2 minus 1, 1 divided by 2. It should be. Why? Great. I'll sit down. Wait, hold up. Wait, why is right cell? Okay, yeah, that actually makes sense. And then cells is 4. And then, right, never mind, that makes sense. So 2. Okay, then it does figure that, that we can't. Look. Oh wait, wouldn't it be the other way around? Oh yeah, wait, no. Dang it. Wait. It might be the other way around for this thing. We can only... If it is... If this thing is greater than or equal... If it's greater than k, then we can traverse it. So if we choose 2, then we can start here and go down here. So it should be less than or equal to k, I think. Okay, that's neat. So where are you breaking here? What the fuck? Ah! It is indeed traversing. That's great. Okay. Let's just so I guess okay, I should probably put this above the other statement actually, so they're more clear. So we guess 2, and then we try traversing, and then we queue up. Wait, why are we queuing up 0, 0? Wait, is it because here? Do we want to do this, maybe? Okay. Hopefully that fixes it. And hopefully we don't TLA. Okay, that's 1 millisecond on just the run cases. That's not looking great. Okay, we time limit exceed. Why am I printing stuff still? Where am I printing? What the is that? Oh, because I'm printing here. So if I run this here. Okay, now that's 0 on this. Okay, I still time limit here, which isn't great. Why? Maybe, is it because of BFS? Perhaps. Maybe because I'm always allocating new space. So we said would it be this one's that's not even that big of a matrix really. Okay, this is a big game, but I equals 0 less than rho plus I. Let's see. Next step, fill set I to false. That make it run any faster. And it's 78 out of 118. Okay, so that doesn't help at all. Yeah, I just wrote like a really bad BFS. Jesus. Okay. Huh? Would it just be more efficient to Okay. This one's a little rough. Is it the way I wrote the BFS? This is how you write a BFS, is it not? DFS int matrix int k. Boolean set. Set. J, and then set ij is equal to true, and then we just do a for int direction in directions. You see, I'm just copying this. Uncomment. Continue. Otherwise, let's see. Shoot. Let's see if DFS matrix K set EIDJ, then res is equal to true, and res, that probably works. So bad. I would probably have to adjust that up there too. Continue. That probably checks out. Look at false. Type 0 I is less than. Let's just say call. Plus I. If DFS matrix K set, and then we start at I equals 0, and then I equals 0 and I. That's a bad name for a variable, but whatever. Then res is equal to true. Okay, we should probably break them. Okay. Valid. True. Break. Then also we want to check if matrix 0 of I is greater than K. And that break. No. Greater than mid. Mid. Oh. Man, this is bullshit. Oh, because we never actually. We say if I is equal to the matrix dot length minus 1 return true. Please? Yes? Submit this. Watch it not actually change anything. Oh shit, it actually passed. And we did pretty well. We did better than half of the people. I wonder what the better solutions did. Oh, these union. Yeah, I'm not touching union fine, but I feel like this was a very fun binary search problem. I don't do enough binary search. I guess, yeah, BFS is not very... I think you could solve this using BFS. I just don't know how to write good BFS. I guess looking back, DFS, we can break early if we find a valid path starting at... I think the way I wrote BFS, we store a lot of useless cells in the queue. But we'll have to study this stuff. It looks interesting. Okay. No, I did now. I think I did pretty well. 40 minutes, not that bad either.